Hello, everybody, and welcome to the third event or the second virtual conference of the year for this joint team. This joint conference is brought to you by the Red Team Village, the DEF CON Red Team Village, and Texas Cyber Summit. Our goal with these 1 and 2 day events is to first provide quality training from well-known and respected cybersecurity professionals in our industry, and second, to educate as many people as possible for free. And third, to get a better handle on the streaming and collaborative technology we use in these virtual events. We have DEF CON coming up in August, so we want to be prepared for that as well. And then finally, and most importantly, any money that we raise goes to charity. And then finally, we're providing these briefings and workshops for free. We have a high quality of standard for ourselves, and our mission is to provide you with the best possible experience. Please understand that things may and will likely go wrong during the next 2 days, and we ask for your patience. Our lineup over the next 2 days is 23 briefings and 16 trainings, 16 hands-on trainings. Thank you to all of our speakers, trainers, and volunteers who help make this possible. And now Omar will discuss the other events taking place during this 2-day event. Omar?
Awesome. Thank you, Joseph. And I'm between you guys and an amazing speaker, so I'm going to be very, very brief. We have a very, I guess, an honor to have a lineup of speakers, as Joseph mentioned, but we also have 2 amazing contests today. We have an awesome CTF that if you haven't registered, please do so. I think that actually just started right now, so we probably you're a little bit too late. We also have an esports. It's the first esports event for cybersecurity, scenarios, and so those 2 are competitions, and we're going to announce the winners tomorrow at the closing ceremony. So stay tuned throughout. Please participate in our Discord channels. That's where most of the conversations are actually going to be. All the speakers are going to be hanging out in there. So thank you again, and I'll pass it back to you, Joseph.
Thank you. And our event is named Jungle after June, and or Jungle, misspelled a little bit. And our keynote for the Jungle event is a headhunter instead of a keynote, get it, is none other than Mr. Paul Asadoorian, who will not be doing a keynote, but will be doing rather a technical talk on containers. And now I am going to turn it over to Paul. Thank you, Paul, for joining us.
Joseph, Omar, thank you so much for having me today. It's a great opportunity to present and share some of the things that I've learned about containers and spent some time banging my head against the wall, and hopefully it helps all of you out there. So let me just share my screen, get my slides going. Hopefully I've got all my notifications turned off. I'm sure we all go through that. So this talk actually stemmed from about a year or so ago. I committed to running with myself and Matt Alderman, running a container security day for InfoSec World. And it was originally about migrating legacy applications into containers. I've kind of changed it into really migrating any application into containers. And we'll talk a little bit about the differences between your own software or your organization's or enterprise's own software being inside containers and open source software that you might configure inside of containers, or containers, oftentimes in my case, in most people's cases, I think contain both. So that's where everything here is kind of relevant to what you're doing, whether you're writing custom code or deploying other applications that are open source or commercial for that matter. So just a little bit about the agenda. So the good, the bad about container deployments. I've been doing container deployments hands-on. I started in like 2016 or 17 or so, maybe 4 years ago. I took our internal application, which we lovingly call PPWorks, that does all of our podcast automation today. Back then, it was largely just publishing, and I took that and put that in containers, and I've been, working on that application ever since. MediaWiki, as some of our listeners may know, if you go to wiki.securityweekly.com, that's a wiki that we use to host all of our show notes pages, and that's deployed on containers as well. So I actively help maintain and develop both of those applications today. And much of what's in here is really what I've learned a lot with those 2 deployments and some other testing that I've done as well. I've got 6 tips for deploying and securing containers. Regardless, of your deployment, I think it's really important to understand that the basic building blocks and fundamentals inside the container will stay and be a constant no matter where you're deploying your containers. Now, other security layers and options and configuration need to be added when you do things such as Kubernetes or you deploy out to ECS. I unfortunately don't have any Kubernetes examples. I do have a couple of screens about some ECS. I did a sample, kind of an experiment in Amazon's ECS or Elastic Container Service. Have not done much with Kubernetes yet, but look for future presentations later this year as I start to evaluate Kubernetes. And many examples of some working configurations and things that I've done, pulling stuff down from Docker Hub, changing it, and making it my own. Of course, I wish we could all be in the same room and hanging out together. Of course, with COVID-19 makes that very difficult. But memes and my salt gun and scotch have been really keeping me going, being at home. So let's talk about the benefits of moving to containers. Why would you actually want to put something inside of a container? It is becoming more common today. A lot of people are moving to containers and even cloud native services, which are using the cloud provider services to deploy your applications. Just kind of, and I have a chart that'll show you some of the options there. I think from an attacker's perspective, you're probably going to find that more and more web applications are living inside of containers. And that's largely because it's very easy to duplicate environments. That's one of the biggest pluses from a defender's perspective, because I can spin up an environment and test it and then spin it down. I can, upgrade all of my packages and libraries, spin up a new container set or, multiple containers that run the application and see if my updates actually worked. I think this is really, for me, my first initial impression was this is great for, applications, especially legacy ones that are using older frameworks, components, libraries, and operating systems in a way to test that, get it up on a stable platform, and then start to iterate on upgrading all of those various components that your application resides on top of, and be able to test those as you go. So if you're Tomcat version 4, you've got a lot of work to do, right? Containers can really help you get there. Now, scalability is another thing. I think that speaks to, the ECS services, Kubernetes, and lots of other container-based services. But containers do allow you to break apart your application into multiple pieces and afford some scalability as you can spin up multiple containers to handle the load. I already touched upon some of the security use cases inside of, putting your app inside of containers. It does really speak to reducing your attack surface, and I'll show you how to do that, at least in my experience, what I've done to reduce my attack surface. Now, the downside, again, you're going to take an application, maybe it's a new application, maybe it's an older legacy application, and you're going to put it inside of a container. And what I really like to stress with folks, whether we're talking about any type of virtualization and any type of containerization and or microservice, it really doesn't matter. If you've got an application that's basically a flaming piece of crap, and you take that flaming piece of crap and you put it inside of a container, you're still going to have a flaming piece of crap. It's just running inside of a container, right? So I think a lot of people, and don't get me wrong, it is a good step to take your legacy application, whether it's a flaming piece of crap or not, I guess is somewhat subjective. Put that inside of a container. That's a good first step. But realize there's very little inherent things inside of containers that will improve your application natively. You still have to fix the security holes inside of your application. Legacy code is especially troubling, as oftentimes, as many of us know, the developers may have left the organization and left behind that code that no one wants to touch because it works. So some of the downsides are security. Actually, Docker Hub is getting better Some of the examples on the internet are getting better, but when you're a developer or ops person or whatever, and you're looking to deploy something on a container, if you don't pay attention to where your configuration's coming from, it very well may work great, right? But there are underlying security issues inside of a lot of those configurations. And I think as developers, especially, you're like, oh, I just need a Linux environment with Node to run my application. So I'll go to the internet, and the first couple of results, I can build my container. That's going to give you a container with thousands of vulnerabilities. And that's just in some of the packages and dependencies inside the operating system and inside of Node as well. So there's also a complexity standpoint as well. It is more complex working with containers because you have to know the configuration of all your containers. Your application then may spread out into multiple containers. You may have configuration of your GitHub account over to your Jenkins build automation. You've got, if you're in Amazon or some other cloud, you've got their code to worry about, their configuration. You may write code. You may use Ansible scripts to generate Terraform scripts to generate your environment, inside of Amazon, and all that gets really complex really fast. Also, containers heavily favor Linux, and I've done a little bit of reading and talking with folks about Windows containers. They do have to run in a Windows environment. The last I heard, like late last year, a lot of the feedback I was getting was, people are using Windows containers, but not really using them in production. It still wasn't quite ready for some in prime time. Of course, if you are using a mixture of different containers, and some of those are Windows, and you're doing that really well, I'd love to hear from you. As most of the feedback I've gotten is it's not quite ready. So this presentation will very heavily focus on Linux and in Linux-based containers. Okay, then it comes down to who's responsible for security. And once you start building containers, you're going to need a place to host those containers, and you're going to have to make decisions. And this isn't just one decision about one application. Every application might have a different deployment path. Your application may have some components that live on premise, some components that live in infrastructure as a service, some components that live in platform as a service, some that live in functions as a service, and some may even be in software as a service. Our own application that we use today for Security Weekly to publish every single one of our shows and do all the business automation about which hosts and guests and stories and all that is really a combination of all these columns. We use different pieces of infrastructure. We rely on other API services that are SaaS based. We've got on-premise infrastructure to be able to record all of our stuff as well. So the responsibility for security shifts. And, as you rely on other people's infrastructure, the further right you go on this chart, the more of the security is really on the provider. However, you still have some responsibility for security, even when we look at SaaS-based applications. When we look at functions as a service and software as a service, we lose that container security layer. You can see that container turns from blue to purple. We lose that container layer, so we're not necessarily responsible for the security of the container, but we have to make sure that our application and our identity and the configuration inside of the various cloud and application providers are configured correctly. So our job doesn't end as security. And like I said, everyone chooses a different path for every application, and even pieces of the application that go across this chart, which makes it very difficult for blue teams and ops people to maintain the same security as they did when we really only had that column on the very left for on-premise. So as I said, one just doesn't simply move to the cloud, especially in the times of this global pandemic, when many organizations are now readjusting priorities and looking to move to the cloud. More and more folks are recognizing that this journey is not straightforward. So, obviously you have on-premise, you could host containers on-premise. Some people build basically their own cloud, on-premise, and that's an option. As you move into the cloud, I use Amazon as an example because that's where we're doing a lot of our development. Of course, Microsoft and Google have options to do basically most of the same things that Amazon can offer inside of the cloud. So now you want to take your container, you want to pick it up, you want to move it to the cloud. You can run it on Amazon's EC2, you can run it in Amazon's ECS, or you can run it in Amazon's EKS, which is their hosted Kubernetes. And again, this goes across multiple cloud providers. All three of the major cloud providers do offer hosted Kubernetes. What I've heard is many enterprises, and especially if you're a red teamer, right? This is important to learn how Kubernetes works. A lot of people get it wrong because it makes the configuration very complex and was not designed in the beginning for security. But a lot of large enterprises are deploying Kubernetes and they're going, I want to move it to the cloud. And then they do the deployment and they get the build and they're like, wow, that's really expensive. I want to move it back to on-premise where I can control my costs. But it's still Kubernetes and it still has all of the flaws, especially the underlying ones we'll talk about today inside of containers. I won't touch too much on the cloud native stuff. If you want to know more about that, you can ping me afterwards as well. And if you really want to dig into it, our full-time developer here at Security Weekly is working on a deployment very similar to the cloud native one. So defining your environments, right? This is largely what we'll be talking about today. You've got a Linux host somewhere. Maybe that's an EC2 instance. Maybe that's local. You've got Docker, and you've got your containers on top of it. You may also have Kubernetes thrown into the mix. When you do, you still have your container config, and these containers can be your, a simple Linux box. It can be a prepackaged MySQL server that you're pulling down, some other kind of open source application such as WordPress, or you could have your own application written in Node or Python or some other language that's being deployed on containers, or you could have a mix of them that make up your application. I wanted to talk a little bit about this kind of changing shift into how we do security. And I think what's more interesting for me is not so much the indicators of compromise, which is interesting, but it's how a lot of the dynamics change on a lot of the teams. We did a great interview with Heather Adkins. She's one of the lead security engineers at Google. Awesome individual. She came on the show. She wrote a book about how engineering basically has changed. And I can provide a link to that interview because it was really eye-opening to see how, we're traditionally responsible for security as security professionals, and we think of, indicators of compromise as we need to gain visibility into the host. We need to gain visibility into the network logs and maybe have some threat intelligence. And these are kind of my four, what I call enchanted quadrants that I use as, to talk about things like indicators of compromise. And all of these things get different and sometimes more difficult. For example, if you're looking to do some network tapping, it's really some new innovation that exists inside of Amazon's cloud that allow you to do that in the cloud, which is really cool, but it's not always available to collect. Even in Amazon's cloud, they give you a great facility hooking into a VPC, hooking into your network interfaces in the cloud, doing a traffic mirror, but when you start using some of those other cloud native services, that traffic can be somewhat elusive. So a lot of the traditional security things are still there. They just might be a little more difficult to access. And again, with the host, going back to the earlier chart, going to the host level, you may not have access to the host level. You may just be running a Lambda function, which is just running your Python code, for example. So the blue team enchanted quadrants, just really briefly, this is kind of how I break down the four major areas for the blue team to apply security controls, which all get different when we talk about containers, right? Specifically, asset management and vulnerability management gets super difficult because of the ephemeral nature and the immutability of containers. Means they can spin up and then they can spin down very easily. They can be replaced by a new version, usually several times a day if people are using a DevOps style approach. And that makes things like vulnerability management Well, different. I mean, somewhat, different challenges, but also an opportunity to provide that continuous loop where I can continuously update my application. That's a big plus for me in vulnerability management. It makes asset management very, very challenging due to the immutable nature of containers. Where I really wanted to spend a little bit of time talking about the security skills, because I'm like old now, right? I'm in my 40s, and I've been doing this, this for my entire career. And I have these like kind of preconceived notions of what our role should be inside of IT and in programming. And traditionally, right, you had the security person, you had, the platform or the sysadmin or the infrastructure person, you had the network person or teams of people, right? You had the programmers and software developers, and we all kind of worked independently, and we maybe shared some things as time went on. Now, when we look at how we're deploying applications, specifically containers and DevOps, so DevOps as a process, containers as a technology, coming together along with a whole bunch of other things to string along the continuous integration and continuous deployment. When you look at how we're deploying applications today, these 4 different roles could really be one role, right? And now, not to say there aren't security people anymore, won't be security people in the future. There'll always be security people in my mind, but a lot of the roles I think are going to change. Heather did a great job of explaining this, because at Google, this transformation has really already happened, and Heather and her team were part of that and share some of their knowledge about how, they basically had to change the skills and change the team dynamics between security and sysadmins and networking and programming, right? Because as a software developer, you're going to need to know about operating system, networking, and security stuff because you have control over that. Same thing from the networking side, and sysadmin side. Now you're going to have to know programming. So if you're trying to get into this field or get into any kind of technology field, we're using cloud technologies, you have to have this diverse skill set, because you're likely going to be writing code to create the infrastructure. So it was a great, I think, kind of a awakening to see how that dynamic will change. So as you go through and you learn about, in the next slide, about how we actually start building some of these containers securely, realize that it might be different people on your team that are doing that. So these are my now 6 steps to securing your Docker experience, right? Use Docker. It'll be fun, they said, but they don't always tell you about some of the security things that you need to do, such as building your own containers, implementing your own registry, not running containers as root, and not running them with additional privileges. We're going to separate Linux user permissions and privileges from kernel and additional privileges that can be assigned independent of the user. We'll talk about multi-stage builds, protecting secrets, and how to do some vulnerability management using open source tools. In fact, everything I'll talk about in these, there's actually 7. I don't know how I got 6. I guess I'm really bad at math, but we will talk about vulnerability management as well. Okay, we'll start with building your own containers. Now, certainly you can pull down a container from Docker Hub and be off to the races. However, if you don't choose your base image wisely, you could get yourself into trouble. This is a sample from NPM, Node Package Manager system, that's installing a Node application. And there's a lot of issues even with just these few lines inside of this file. For example, that first line right there is one that I pick on all the time, because you have to choose your base image, where your image is coming from. Now, Node:8 will pull down Node version 8, but it's going to make a lot of decisions for you about what the base operating system is, about what packages and dependencies are installed. And at the time when I wrote this presentation, maybe a couple weeks ago, to pull these numbers, it introduces 2,418 vulnerabilities into your environment just in that first line. Now, Docker Hub is working to make that experience better, but it's really super hard due to a lot of different dependencies to be able to build a clean container image that doesn't contain any vulnerabilities due to dependencies. However, you can get those vulnerabilities down to a manageable number by doing a little bit of research. Sneak puts out some great research. They've got some open source tools and some free tools out there, which is one of the reasons why I mentioned them. They're also a sponsor of the network, just throwing that out there as full disclosure. However, even before they were a sponsor on the network, I used a lot of their research to make the decision to be able to choose wisely as to which container platform I was going to use. And they look at the number of OS vulnerabilities by Docker image, and they publish these for you to freely look at all of this data. In fact, they're working on the next report, which may even be out by now, or just coming out very soon, where they're analyzing the open source vulnerabilities inside of open source vulnerabilities inside of open source software inside of Docker images. So you can just see number of vulnerabilities by Docker image. Node, of course, very, very high. And then as we go down, Ubuntu does not have clearly as many vulnerabilities. So this is your first step into choosing wisely. Also, there was a great article, that was published last year that basically shows some of the ways in which these default Docker images are vulnerable and why you shouldn't use some of the defaults. And that's a great article as well. And these are two articles that I used as a basis for some of my research. So what I've done is, in my choosing wisely, you can go in a couple different directions here. You can, build your own Linux distribution, and that is certainly an option, right? So you have to pick a starting point. Inside of Docker, in your from line can be like basically start from scratch. I can't remember the exact term because we don't actually use it here at Security Weekly. And that basically requires like you can build your own Docker image and Linux distro inside of Docker. Now, with that great power comes great responsibility because you're now responsible for all of the dependencies and all of the security fixes. So it's a lot to take on. I agree from a configuration perspective. If you're a Gentoo user, for example, that might be a place where you start. Just realize that there's a lot of maintenance associated with that. Where now you can also go the other end of the spectrum and choose Node 8. That's going to get you into trouble. It's going to get you lots of vulnerabilities because they're trying to give you so much software in there. There's so many dependencies, and it just breeds a lot of vulnerabilities. Where I like to go is somewhere in the Ubuntu 2004, which is a very slimmed down latest version of Ubuntu, a good slim image to start with. And then I also use a lot of Debian Buster Slim. The slim images are great because you don't have to build your own Linux distro, but they give you a really slimmed down version of Linux to start with, which is where I usually use Debian Buster Slim. Ubuntu 2004 still has a lot of newer, really newer things that can break some dependencies, but I think in time that might be something that I play around with a lot more. So make sure you choose wisely. Again, I like the slim image. I like Debian Buster Slim, and I'll show you just some comparisons later on as to how many vulnerabilities are in Debian Buster Slim versus some of the other ones that have a lot more vulnerabilities. So when I build something like a Python container, for example, I don't do from Python 3.5 or 3.7 or whatever you want to use, because that is leaving it up to someone else to determine what I need for tools and dependencies and all of that stuff. So what I do is I build a Debian Buster Slim. I define which packages to install, and these are requirements based on my application. Now, in some of these other images, if you're just installing a generic Python 3.5, you may see a lot more packages in this package list because they're trying to make it work for more people, which in turn leads to more vulnerabilities because you have more packages and you have more attack surface. So I customize my package list to support my application, and I know exactly which packages I need, and I pair them back as I go, see what breaks, so that I come up with a nice succinct list of packages. I like to create a Python virtual environment inside of my container. I think it's a much cleaner method so that when I install my pip requirements, they're going inside of a virtual environment, and it's just a much cleaner way to do that. And then, of course, I install my packages from the operating system without installing recommended packages, so I get a slimmer image. I put it in a virtual environment, and then I do my pip install, and I install my pip requirements, which goes inside of that virtual environment. So that's how I get what I feel is the best kind of balance of a nice, clean, small footprint container image to run something like a Python application. The next thing you're going to want to do is, since you're building your own containers and container images, you're going to want to go out and build your own registry. Now, you can build that in Docker yourself. And I've done that, and it works fine, and you can host it yourself, and it's not really that bad. The one thing to really pay attention to when you have your own Docker registry is make sure that in that red circle down the bottom of the slide, make sure you apply security to it. Make sure you put authentication, configure TLS correctly if you're going to do that. A lot of the examples on the internet gives bad advice. Sometimes, most of the time, your mileage varies. You can get bad advice on the internet. And a lot of the tutorials will show you, hey, stand up your own, local Docker registry and not configure TLS. And that may be okay from your perspective running it internally, but then you may realize that you need to put it up in the cloud or move it around, and now it doesn't have security. And basically, if you're leaving your Docker instance via the API, like a Docker API exposed port or a Docker registry exposed port, it's pretty much like having ClearText Telnet protocol open with no username or password. And it lets anyone do anything on your registry or your Docker instances, APIs for the Docker server. So don't do that. Make sure that you spend the time and configure TLS correctly for both of those. In this case, it's the registry. Amazon's ECR is actually pretty cool. If you're doing an AWS deployment, I really like it. You do have to pay attention to the security there as well. There are rules to configure in Amazon's ECR. There is a specific policy. So you have to configure AWS roles. You have to configure policies. And then there's like a firewall rule manager for ECR that you kind of have to work your way through and read the documentation and make sure that it's locked down so that you're the only one that's updating and adding images into your repositories. Docker Hub is also a great option as well. We actually use Docker Hub for some of our deployments, and it's a great way. It's not expensive, and you can basically have private repositories if you give them, a small amount per month is the basic. We have 5 repositories up there, and it's a great way to get, a secure registry without building it yourself, or if you're not in Amazon's cloud, for example, maybe you're not going to use ECR. So Docker Hub is a good one as well. Okay, this is one of my biggest pet peeves. From an attacker's perspective, it's really great because people run containers as root. So once you get a command shell, on the web application or some kind of command execution, you're just root, and it's awesome. And you can have an easier time of escalating from there and basically take over the Docker host because they're running as root, which makes your job much easier. Of course, you shouldn't do everything as root, and we know this. Yet, so many examples from Docker Hub, when you pull down container images, run as root by default. And again, I think this stems from that balance between usability and security, making it more usable for people to just pull down that image and have stuff work versus making them work a little harder to not run as root, which could break their application and or deployment. So, if you don't believe me, here's a little exercise we can do. Create this very simple Docker file, which pulls PHP 7.4 FPM, which is the application server for PHP. I use it in one of my builds. And when I was evaluating what I wanted to use for a container image, I was like, wow, they just straight up run it as root. And so you can build this container, you can run it, and then you can execute as that third line there, Docker exec. And when you get a bash shell, you can see that you're root. I'm like, well, that's not going to work. I can't be running these containers as root. And I hope that as we start evangelizing this more and more, that more of these projects, open source projects that are maintaining these Docker images, really come around to not running them as root and really make them run as not root by default. So to not run as root for PHP FPM, you've got to jump through some hoops, right? It's a little bit of work. It's not bad for PHP FPM. It's actually not that bad, right? You got to create some directories, change the user permissions. So the www group, I believe, exists in that in my container image by default, or in a container image by default, or previously in the Docker file. You're creating that user www along with the group, assigning the permissions. You have to create the log files, the PID files, change those permissions. And then the most important line is right before you execute what's going to run inside the container, drop your user permissions down to your www user and run your application. Again, it's really not that hard. So, some extra steps in there to be able to run things not as root. Now, Nginx is a little tricky. And I know that the master process for Nginx runs as root, right? And then you've got all the child processes that run off of that run not as root. But what happens inside of a container is, if that one process is running as root, it means that container is essentially running as root, which means someone could gain root level user permissions inside that container. So why not drop the whole thing down to a lower level permission and be able to run Nginx not as root at all? Because inside of containers especially, it doesn't need to run as root. Really, the reason it needs to run as root primarily is to be able to listen on port 80 and 443 because they're less than 1025. And in Linux, you need to be root to listen on those ports. But in container world, you can just make those port mappings. You can see in the box I have there, basically, the Docker engine is running as root, and it has those permissions. It can listen on port 80, map port 80 into port 8080 inside the container, which means now your containers don't need to run as root. And again, doing that, basically adding a user, changing some permissions, creating the PID file, changing its permissions, and you're basically off to the races there. The documentation's actually on the Nginx Docker Hub page. They just don't do it by default. Allowing Nginx to read from the environment, and we'll talk a little bit about some tricks to get your secrets and usernames and passwords out of your configuration files and minimize your risk of those getting checked into GitHub. I had to do some interesting things in the Nginx config, and again, this is documented on their Docker Hub documentation, and I just made some modifications to that. But essentially, you've got to have a template that has variable names in it. You can see down the bottom, listen, Nginx HTTP port is an environment variable, so that's my template. And then I run a command called env substitute, or env subst, right? And I take what's in my template, I substitute environment variables from the Linux shell environment, and I create the Nginx config on the fly. So this allows me to put my credentials and other things that I may want to specify in the build process that are expressed as environment variables that end up as configuration inside of Nginx. So that's how I'm doing that right there. So there's a little bit of trickiness to get that to work, but it's not that bad. Now, let's talk a little bit about additional privileges. I was explaining this to one of our folks here who's learning Linux and learning about sudo, and I finally got to tell him the sudo make me a sandwich joke, and he got it. But there are privileges inside of Linux that go beyond your user permissions, and these are very applicable to containers. The first one is seccomp, which is kind of interesting. These are secure computing filters, if you will, inside of Linux that allow you, is one mechanism that essentially allows applications to have privileges that are outside of their user privileges. Now, where I found this very interesting in particular, and again, you can go read the technical details, and they're really awesome. And if you're getting into container breakout, you're definitely going to want to read through some of those things because it's basically some syscall filtering. And you can remove those filters when you initiate containers and instantiate a container on a system. You can say basically, run it without any seccomp filters. And one individual wrote a great article that I linked to in that gray box right there that was basically did some performance testing and said, hey, when I run Docker in seccomp unconfined, which means I don't apply any seccomp filters, I see some great performance improvements, which is kind of interesting. And when I optimize my code, I also see performance benefits. So there are some definite, performance improvements, and they say that, which gets me really concerned that this article exists. The developer is going to go off and they're going to start, removing these security controls to gain performance rather than optimizing their code, which has a very similar performance increase by optimizing your code. All documented in the article, all great stuff. And so Linux capabilities is the next kind of filtering, if you will. It's capabilities, I'm sorry, it really isn't just filtering. It's basically granting these kernel privileges to an application. A great way to think about this, most of us have probably used Nmap, right? And you know that when you do certain types of port scanning, lowercase s, capital S for SYN-scan, Nmap says I need to be root to do that. The reason it needs to be root is because it needs a certain Linux capability. AF packet, I believe, is the kernel function that it needs to be able to create raw packets. Well, that's just a Linux capability to say I can grant this process the ability to create raw packets, even though it does not have root privileges or is running as root privileges. And so what you can do, it's actually documented on the Nmap wiki, you can run some commands, you can grant the Nmap binary the privileges to create raw packets. There's actually some other capabilities you need to grant it, and then you can run Nmap without being root. Now, obviously, I don't recommend that people do that because we want to have these restrictions on processes. We want to have the barrier of knowledge of the root password or the identity to be able to protect our system, because it is a security exposure. It basically means any user on the system now doesn't need to be root to access a binary that has escalated privileges inside of the kernel. So when you run containers, containers have a certain set of privileges, and you can add to those privileges, you can drop them, and this is where we get the concept of a privileged container, which means this container is running with all of the Linux kernel privileges, which essentially means it's running as root or as close to root as you could conceive. And that comes into play very shortly too. But first, just AppArmor. I love the description of AppArmor. It's essentially another facility inside of Linux to limit what can happen on a system and access to these more sensitive areas of Linux, basically. So basically, it controls attributes to programs rather than users, and confinement is loaded into the kernel to further confine a process that's independent of the user, but specific to the program. So AppArmor profiles can be assigned to containers. In fact, one gets assigned by default every time you spin up a new container on a Linux system. And I believe that is the default template that Docker has chosen to use when they're spinning it up. And you can change the profile or disable it altogether. So you have to be careful that your developers and ops people aren't manipulating any of these things, because basically what these will lead to are container breakout vulnerabilities. These are really super awesome and super nerdy, and I love them for that. I do want to give a shout out to Pen Tester Academy. I'm sure some of you have probably been in the attack lab inside of Pen Tester Academy. And inside of there's actually some container breakout exercises, which is where I got some of this information, which is why I wanted to recognize Vivek and his awesome team of folks that he has at Pen Tester Academy. And so there's basically these are based on capabilities. You can, for example, if the container is running in privilege mode, let's say, and it has all of the capabilities that are accessible inside of the Linux kernel, and it's not running as root, but it's running in privilege mode, essentially one of those privileges is I can create a kernel module, load that kernel module into the kernel that basically gets run as root, and that kernel module can shovel me back a root shell. And that's some of the dangers and fears that I have of people running containers is we can circumvent this. Another great Medium article that talks about a different type of capability that could be granted to containers that abuses the file system to essentially gain root access and break out into the host operating system. So some great reading there, and again, great exercises. You can actually do some of this stuff inside of the attack labs at Pentester Academy. Okay, multi-stage builds. This is a really great capability and function inside of Docker that I wish more people used. Essentially, you can create a staging environment in your build process. So it's like a staging environment inside of a staging environment. And what this means is I might need to compile some things, configure some things that require some additional tools to be installed, but those tools don't need to exist when I push my container out into production. Well, you can do this right inside the build process and do a multi-stage build. And what happens is in my from line at the top, you can see I'm going to build a Buster Slim, and I'm going to name it my compile image. So you basically start a Docker image build, you start building layers, and you give it a name called compile image. Now, in this one, it happens to come from my MediaWiki build. And now when I did this, MediaWiki did not have a multi-stage build in order to build MediaWiki. So I created my own that did a multi-stage build. And you can see when I run these commands down at the bottom, I'm installing curl, I'm installing git, I'm installing some unzip utilities and some PHP libraries. These are required for me to build all of my stuff. And when I go to, so this was the next slide. So when I go to now build my actual build image or my production image, there is a line in here, the third line down, not including the space, or empty line rather, where it says copy -- from compile - image. What that's doing is taking the result of my compile commands, all of my curling down a plugin and using GCC to compile something, and it's taking the result of that and it's just copying it into a directory in essentially my new container or my build image. So I'm taking the results from the previous stage, copying it into my current image. I'm reducing my privileges down to a non-root user, and I don't need to install Git and curl and wget and some other PHP libraries because I only need those during the build stage. So multi-stage builds are awesome. You should absolutely use them, and they're a lot of fun to configure and code, actually. Okay, so the next thing you'll need to worry about is managing and protecting secrets. And a lot of people get this wrong, right? You see a lot of, if you're a pen tester out there, or you're a developer, right? And you just know that sometimes a key leaks into your Git repository, and that's bad. Or your secrets are not being protected and they're in clear text files that people can read, and this is bad. And trying to protect these is somewhat difficult. Now, the right way to do this is using a vault of some kind. And I'll show you an example where the Amazon AWS service for protected store is what I'm using in their like sysadmin something module. It's on an upcoming slide. And that's one way. So basically, you can store your credentials inside of a vault inside your cloud provider, right? AWS Secrets Manager. And there's a couple of other facilities in AWS. And other cloud providers have a similar facility in the concept of a vault. You can also use a HashiCorp vault and store your secrets in a HashiCorp vault. Those are much better ways to do that. However, if you're doing development or you don't have a vault deployment yet, and you just want to work to store your secrets, if you look at this particular configuration, right, I've got some SSL certs I need to protect, and I've got database usernames and passwords that I need to protect as well. And maybe I've only got my vault that's up in the cloud, but I'm developing locally and I still want to protect my secrets. So this is a pretty good use case to do that. Basically, you store your secrets only in your .env file, which stores environment variables that are automatically read by Docker Compose at execution time. I ignore all of my .env files, so they're local to my system. Again, not the best approach. The better approach is to use a vault. But using this workaround, what it allows me to do is not have my clear text database username and password inside of the configuration file, right? That may exist inside of the environment, which is, again, the use case for the vault. But to just get it out of my file so that if I check in my configuration file, it's not in my configuration file, and it's not just hanging around as a, in all different iterations of a configuration file. Basically, the credentials only exist in your .env. Then when Docker Compose runs, it reads those into arguments inside of the Compose file. Those arguments are then passed to the Docker file. The Docker file then takes those and writes them into the container image, actually writes the environment variables into the configuration files inside of the container image, and that's read from the environment at runtime. So there is a piece where you have to inject these into the environment at build time, and that's exists on the build server. So this does help reduce the amount of credentials and where they are. Again, a better solution is to use a vault. And AWS gives you a much better, in AWS Systems Manager, which is an AWS service, there's the concept of a parameter store. Inside of the parameter store, you can store things such as your database username and password. And then if you're deploying your containers in Amazon's ECS, instead of putting the clear text username and password to your database inside of ECS, you just point it at the parameter store, and through AWS policies and roles, you grant that ECS access to that credential, which gives it a much better way to protect your secrets. So it is essentially, this is sort of like using a vault, although it is not a traditional vault as we would think of from HashiCorp or Conjure from CyberArk. So now to manage some of these secrets, it's kind of interesting. So we show an initial configuration that we're using randomly generated passwords, which I think is actually cut off on the slide. Essentially, at build time, what I'm doing is injecting the username and password into the container system. If I'm also building the database container and resulting image in my build process, I can build a new database image, give it new credentials, put those new credentials inside of my application server, and every time I build, I can have a different set of credentials. So if my credentials do become compromised in some way, it doesn't matter because I'm basically randomly generating those at every iteration. And that's configuration dependent. And really means like you're not using RDS, right, or the database management service from a cloud provider such as Amazon, that I have an actual container that's running my database. If you do that locally for our builds, this is what we do, and we just randomly generate the passwords. Again, that minimizes that an attacker who does gain access to a credential has the keys to your kingdom or all of your kingdoms, right? If it's randomly generated every time. And there's basically just an OpenSSL command, which got cut off here, I apologize, that generates a random password, and it does this at build time. So every time I rebuild my environment, I can generate new credentials. You will need to customize some of your applications. This could be your own locally written application or someone else's. In the case of MediaWiki, it's nice because their configuration is actually a PHP file. And so, and there's a great example on the internet that I probably should have linked to as well, where I got this from. But essentially, you can write some code inside of that configuration file that rather than statically defining your database username and password, you can read it from the environment, which means that your resulting config file doesn't actually contain those passwords. It's just read randomly at runtime. So again, minimizes the risk of exposure of your credentials. Okay. Vulnerability management is somewhat interesting when we talk about containers. And there's a lot of great open source tools. I've tested several. Hadolint is one that I really like, and am incorporating into my build process. The cat in the litter box is not just like a funny random image that I found on the internet. It's actually the logo for Hadolint, which I think is really awesome. But what it does is it basically will analyze your Docker file and tell you about any potential security misconfigurations you might have inside your Docker file. Great thing. It's free. It's open source. You can look at all of its list of things it's checking for. One of the things it does check for gets back to actually, previously in the presentation when I talked about, how much control you want to have. Do you want to build your own Linux distribution, or do you want to use a slimmer image, or do you want to just inherit all those vulnerabilities from using, something like from node:8? In here, Hadolint's saying, look, when you install a package, you should pin it to a version, right? And to me, that's a double-edged sword, because yes, you could pin it to a version that does not have any vulnerabilities at the time. However, when that package updates, it's up to you to go into your configuration and your build scripts and change that version. So I mean, this can prevent you from maybe, version 4 of a particular project had a backdoor because a developer leaked a key or password spraying or whatever, but and I pinned my version to version 3, so I didn't automatically update to the newer version that had that vulnerability, is a use case. However, version 4 fixes a really heinous flaw, and you've pinned your package to version 3, you're going to have that heinous flaw until you fix it. So to me, that's a double-edged sword, but certainly available in your build process and flagged by Hadolint. It's a pretty cool utility. There's lots of software out there, commercial and open source, that's going to scan your Docker configuration, scan your source code configuration, look for what packages, libraries, and dependencies that you have in your source code, in your operating system that exist inside of your container. Anchor's got a pretty cool open source one that I really like to use, and there's lots of them out there. There's Claire and many others. There's commercial ones. Sneak has a free one and a commercial one as well. And really some of the differences between the free and open source are, between commercial and or free and open source are the transient dependencies. So the dependency of a dependency. I might pull in some Python library XYZ, and that Python library XYZ pulls in 3 more libraries, and one of those is vulnerable, and the other one has a backdoor in it. The commercial products do a much better job at what we call transient dependencies. But the open source tools work great for analyzing an image that you might be using or one that you created yourself. So this is just a cheat sheet. I won't go through every command on here, but this is basically, how you get Anchor up and running. It's a cheat sheet I created for myself. The last 3 lines are important. You have to make sure that you add your image. Then you have to wait while that image gets scanned, and then you can report on the vulnerabilities. And what that does for you, and this is just an example of it running, when you run the wait command, it says, oh, I'm still analyzing that image for vulnerabilities. Then it spits out that, hey, I'm done, and your report is ready. And if you look at the report, and this is using Node:8 as an example, of those 2,400 or more vulnerabilities, there's some severity criticals and highs in there that are in that image that you just inherited, right? And that could be from any number of different packages, right? But you can see you've inherited some vulnerabilities. Now, what I like to do is look at Debian Buster Slim, which is one of my favorites to use, and you can see the severity is negligible. It does have some CVEs associated with it, but the severity is negligible. If I go back and I look at Node:8, there's critical, high, and low and medium vulnerabilities in there, whereas Buster 10 only has negligible vulnerabilities. And if you look at the total number, at the time when I ran that command, it was actually 2,386. It grew to 2,400 and something I'd be curious to see if I ran that command today, if we're surpassing 2,500 vulnerabilities that are just inherent inside of that image. When I look at Buster Slim, there's 75, and the severity, because I'm using Anchor to look at the severity, not just the number, is negligible. And that's one of the ways that I like to choose my images, using open source tools to evaluate those vulnerabilities. The other kind of thing in here too is I only use trusted images, or as best we can. Basically, it makes sure that that image has been signed inside of Docker Hub, that someone hasn't poisoned that image with a backdoor, which is a good thing to do. Inside of your environment, in all of your build scripts, if you set Docker content trust equal to 1, it will only pull signed images, which just helps reduce the likelihood that you'll pull down an image that someone has purposely put a backdoor inside of. That doesn't mean someone can't compromise the build process for a trusted image and put a backdoor in there. That's certainly still on the table, but it does reduce the risk of that happening. Make sure that you build up-to-date versions of all of your components. On the subject of vulnerability management, when I pull in other components, so in MediaWiki, I use a couple of extensions. Every time I build MediaWiki, I go out to the extension website, I pull down the latest version of that extension, and I build it. And if it breaks, I want to get an alert that says, hey, I tried to pull down the embed video extension and it broke your build. You have to go fix that before we can push this new version to production. So this means that any code changes, including vulnerability fixes, will automatically be inside of our build process, which is just awesome. And that happens natively inside of the container, right? Most of the time, in terms of building out the latest version of libraries. If you've got a pip requirements file that doesn't pin it to a version, those get updated. But also be mindful of any components like this one that I'm pulling in, and I'm building the latest version always at runtime. Using a small base image, actually at one time this did have a high vulnerability that they fixed. One of the nice things about Amazon's ECR, as well as GitHub, will do some of this as well, is that both these registries and GitHub natively in your source code repository, if that's what you're using, will discover vulnerabilities. So when I check some of these images or push these images, container images, up to my Amazon ECR registry, make sure your scan on push is enabled in your configuration when you create the repository, and it'll automatically get a vulnerability scan from Amazon's service, which is nice. Again, it doesn't handle a ton of transient dependencies, and it doesn't do a lot of the advanced things, such as like, what if I never used curl, or I took curl out of my build process in a second stage? Is it still saying curl's there? I guess it would if it's in the container image. But some of the other libraries, when we talk about code, I may never call the function in the vulnerable library, but since that library is inside of my container, these systems will flag it as being vulnerable. So that's some of the differences between these vulnerability management tools when we talk about containers. So I think I did good on time. And of course, we can't say thank you without a meme. I thought that was pretty funny. I will be in the Discord channel for a while after this if folks have questions. So I'll turn it back over to Omar and Joseph.
Thank you very much, Paul, for presenting today. Amazing presentation. And now, of course, I'm losing my voice. Mm-hmm. Thank you so much for supporting the DEF CON Red Team Village and Texas Cyber. And for all the attendees out there, please feel free to join the conversation at the Discord servers. We will go in a brief break, and the next presenter will be live in around 15 minutes or so. So again, thank you again, Paul, and have a good day.
Thanks, Omar. You too.